There are two more commands that allows you to look for files or commands in your system. Uh, One of them is called locate, and the other one is called which. So suppose you want to locate a particular, suppose you want to locate all the movie files, MP4 for example, on your system. You can just use the command locate with with the star MP4. Then it's gonna look for all the MP4 files in your system. It's gonna give you a list of all the MP4 files in your system. And this locate command is different from find. Find is more flexible, accepts lots of options, allows you to change your search in many different ways. But locate doesn't have that many options. In fact, what locate actually does is that it searches through a particular database. So this database actually contains all the information about the files on your system, and it's indexed and it's updated every night by the system. So it basically just searches through that big database and look for the files that matches this particular pattern. And this database that it searches through is updated every night. So it's not sort of the most up-to-date information. So if you have changed the file system in some way through the day, and it's not reflected in the database yet, this locate command won't be able to adapt to that kind of change. It just looks through the old database without any sort of updated information that's um, reflected in the in the in the in the search. You can force an update. You can force an update of the database. It's called update DB. I think it's update DB, and you can use this use this command to force the update of the database right away. But updating the database is gonna take some time, to especially if you have lots of files in your system. So locate is um, is um, is a way to search for a file very quickly, for a set of files very quickly. Find actually recursively search through all the directories and the subdirectories um, in the real time. But locate just looks into an old database um, that's updated nightly. So locate is quicker, but it doesn't use the most up-to-date information and doesn't have the flexibility as find. That's locate. And there's another file, another command called which. Suppose you would like to find the location of a particular command for LS, and which is going to return the path to LS. If you would like to find a command called GCC, for example, it's going to return the path to that particular command that you are looking for, which. And if you do, we talked about where is before. Where is before. Where is kind of, which is kind of similar to where is, but which just prints out the path to the binary executable, the command itself. Where is actually gives you more information. It's telling you the path of the command and also some other information. For example, in this case, it's actually returning the directories under user lib that contains all the dynamic libraries related to GCC. For example, these and it's also telling you the main page, where the manual page is actually located. So where is actually gives you more information, which just tells you where the command is located. If you would like to sort the content of some text files, you can use the command sort. It's a command that allows you to sort the content of a text file either alphabetically or according to some rules. So let's try to generate some arbitrary file first. I'm gonna make a directory that's called temp, and then I'm gonna echo some text. For example, I'm gonna use -e because I will have escape characters, the new line characters, new line symbol inside of my character. So I'm gonna do uh, I'm gonna do a, then maybe a new line, and then gonna C D B, z sorry, I keep forgetting about the new line x. Let me just put it into a temp abc1 for example. So now if you look at abc1, you're gonna get a few lines. So cdbza, so it's a small case, big case mixed, and it has some kind of a random ordering. So let's try to sort it. So the basic command is just a temp abc1, and then it's gonna sort it alphabetically. um, one of the option that's quite useful is the reverse the order. You can reverse the order of the sorting with the option -R, and then it's gonna reverse the order, reverse sort everything. And if you actually have a text file that's composed of all numbers, for example, um, suppose I'm gonna echo some numbers into it. So 56, 10, 11.2, 11.1, then suppose I give it like a 3.14. I'm gonna put it into a different file, and then if I still do sort temp abc2, it's still gonna order everything alphabetically. It's not gonna rank all the numbers according to the size of the number. So if I want to sort numerically, I have to use the -n option, and this way it's gonna sort the numbers according to their size. So this way, so 3.14 is sort of the smallest number in it, and 56 is like the biggest number in the file. So if you want to reverse the order, then it's going to sort from large to small. And so you can sort numerical files also, and you can also sort a file according to a certain column inside of the file. Suppose I'm gonna let me do an ls. Suppose I'll do an ls. I'm gonna do a long listing of the files that's under my home directory, the files and directories that's under my home directory, and then suppose I want to sort the files and directories according to their size. That's the 1, 2, 3, 4, 5, the fifth column. That's the fifth column. I want to sort the directories according to the fifth column. Because now it's printed in the human readable format. I suspect it's because my AOS is sort of aliased, so you can sort of see AOS is aliased to AOS-H-color. So if I want to escape this alias, I can do AOS LA, and then it's gonna just print out the files and directories without the color, without the -H. So / allows me to escape the alias and switch back to the original binary file. So to the original command. So if I put this into a file, say temp abc 3, for example, right? And then if I do a cat temp abc3, it's gonna display the same kind of information. So now let's try to sort it according to the fifth column. Let's sort numerically, and then k -k option allows you to sort according to a certain column. And I'm gonna do k5, the fifth column. So 5 has to follow immediately after k. There's no space between them. So, and then temp abc3. Now it's gonna sort according to the size of the file or the directory. And if I want to sort according to, for example, do a reverse sort, for example, then it's gonna give me the reversely sorted file. So one last thing that I want to show you about sort is that you can combine it. You can combine it with the ls command actually. LA. If I do a long listing, you can combine it using a pipe. We'll talk about the redirection and how to combine commands in a later video. in this case, you don't really have to put the output of the ls command into a file. You can just pipe the output of ls command through sort by using a vertical bar, and this way it's going to do a listing based on the size of the size of the files or directories directly. So it's going to put the biggest file at the beginning of the list and then smallest file at the end of the list. So this is a combination of two different commands using a pipe. We'll talk about the redirections in a later video. But sort is a quite handy utility, a quite handy command that allows you to sort the content of a text file either alphabetically or numerically, and also according to a specific column. There's also a command that allows you to compare two files and find out the differences. And this command is called diff. Diff is a quick way for you to discover any kind of differences between two files. So suppose if I do a listing of ls-a, I will be able to see two files, .bashrc and then .bash_profile. So suppose I want to find out what's the differences between these two files. I can just do a diff.bashrc, and then that's going to be my first file. I will treat it as the original file. For example, if you would like to track the changes of two different files, and then .bash_profile, I will treat this file as some kind of change file. In fact, these two files are kind of different files, but with some similarities. But I'm going to treat it as some kind of two different versions of the same file or something. It's just for understanding the context of using the command diff. If you just this is sort of the basic usage of diff. You're just trying to look at the difference of these two files, and it's going to print out the differences actually. But how do you actually understand the output? Here it's a line generated by the diff, and if you look at the line, there's a letter inside of it. It's D. D means delete. So you have three kinds of letters that can appear in a line. In a A, D, and C. C represents change, and then A means add. Do I have an A here? So I don't have an A here, but A means add. So you have three types of letters that can appear. Three letters that can appear here: A, D, or C. So D means delete, and then the number that's sort of in front of D is the line number that's in the first file. You can think of it as the original file, and then the 18, this number after the D, is the line number in the second file. And then it's followed by this particular line. This line, the symbol, this particular symbol, the smaller than symbol, means that this particular line is in .bashrc, the first file. But this line does not exist in .bash_profile, the second file. So if you would like to sort of verify that, let's do a less, and then let's just go to and then .bash_profile. Let me turn on the line numbers. So now let's look at line 19. Line 19 in .bashrc is this particular line, and its alias ls. It's defining an ls for alias. So if I go to bash.profile, and this is line 18, but line 19, it's from line 18 to line 19, there's a line missing. That's the definition of the alias. If you go to the previous, that's this particular line. It's missing in .bash_profile, but it exists in .bashrc. So it's the diff command is actually telling you this particular line exists in the first file, but does not exist in the second file. And then you have another example of a D command, D output. So 47, 45. So this is the line that exists in the first file but does not exist in the second file. And then you have this kind of line. So C means changed. So 50, 52, you have two numbers in front of C. That's the starting line number, and then that's the ending line number. So you have three lines, line 50, 51, and 52. That's inside of the first file. And it has changed to line 48 to line 50 in the second file. So what you can see, this is the three lines in the first file, and then these are the three lines in the second file. So the difference is that you have a hash, the pound sign in front of the three lines in the second file. If you would like to verify that, you can sort of 50G. Let's go to 50G. So here it's that's the three lines diff is reporting to be different. That's from 50, 51, and 53, right? So if you go to the next file, .bsh profile .bsh and 48, I think 48 to 50. These three files are like uh, these three lines are like different because now you have a pound sign or the hash sign in front of it. So it's telling you 50 to 52. The three lines in first file are different from uh, line 48 to 50. So the three dash lines is a divider. So the stuff that's the lines that's above this divider is in the first file, and the three lines that's below it is in the second file. And then again another change, that's two lines, 67 and 68 in the first file, and then 65, 66 in the second file. And then another D again. All those lines exist in the first file but does not exist in the second file. So here you can sort of see there are lots of empty spaces actually. Some of the lines are actually empty. It's just the white spaces or new line. So if you would like diff to ignore the empty spaces, there are several options that you can turn on. For example, if you the -w option allows you to ignore all white spaces. So -w, you can think of it -w as white spaces, and then -w is going to ignore the white spaces. And another option, that's -b. -b, it's ignoring the space changes. Another option for white spaces. And then there's another option that's called -i. That's ignoring the cases, big case, small case, and you can also combine all those options together. And there's also another option that's called -q. Q means quiet. It's just going to tell you if these two files are the same or different. Suppose I compare .bshrc with another file that's .bshrc with a wiggle behind it. It's just going to tell me what's actually if these two files are identical or different. This is a short summary about the commands that we have learned so far. We started with how to get some help from the command line itself. I was telling you it's a self-documenting system, so you can try to find the information, find help from the system itself by using all those commands. And all those commands have their purposes, and it's give different amounts of information, give different kinds of information, and you can use that to find the commands that you need and discover the detailed content, what's the purpose, and detailed information about every command. And then we talked about how to navigate through the file system. So the file system on Linux or any kind of Unix system is a kind of a nested hierarchical structure. So you have to know where you are, and you have to sort of go to other places, and come back to your original places. You can achieve that by using these three commands. We talked about the path. There's a relative path, which is a dot and dot dot, and there's also absolute path, where you can start from the root, which is the slash, represented by the slash, and then go to any directory that you want to go to. And then we talked about how to create, how to uh, move around, how to delete, how to copy files and directories. These are some of the files, some of the commands that are related to those purposes. Touch, echo. Touch, it's going to create an empty file for you, or update the date information. The last time you touched a certain file, it's going to change the timestamp on that particular file. Echo, you can echo a text string to a text file or something. Remove files, make directories, move files to other places, copy files, and make links of files. And then we talked about the commands that you can use to look at the content of files: cat, head, tail, less. And then we looked at how to change the permission. What's actually the meaning of a permission for a file or directory? And then what are the commands that I can use to change those permissions or assign those permissions? Change owners, change group. And then we talked about how to find stuff, find files and directories. We talked about the find command, the grep command. The grep command allows you to search for a particular string in a set of files, and it's going to look for files that contain a certain string, a certain search pattern. Locate, it's going to give you the location of a file, but it's similar to find in terms of their purposes, but different from finding in terms of their methodology. Locate is actually looking into a archived database to look for files, and that database is updated nightly by uh, the Linux operating system. If you don't turn off your computer overnight, it's gonna do that update for you. Find is kind of a in the real time. It looks for stuff in the real time. As the file system changes, your find result will be different. Which is a command for you to sort of find out the location of a command. And then we also talked about some other stuff. Du allows you to obtain information about the disk usage of files and directories. Sort allows you to sort content of files, numerically, alphabetically. Diff allows you to find out the difference between two different files. So all those commands are just like the vocabulary that you are trying to build. By mastering those words, those commands, you are actually understanding the entire command line system, and you are sort of getting a handle about how to proceed, how to initiate your self-learning process. So those are the sort of some of the commands that are used most often by people who works in the command line. The Linux operating system is a multitask operating system, which means that at any time you can have multiple, in fact many processes running at the same time. So it's just like a Mac and Windows operating systems. You can multitask. So a single user can run multiple processes on the system at the same time, and not just the users. The system can also issue multiple programs or execute multiple computer programs or processes in the system at the same time. And so at any moment there could be lots of processes running on the system. Some of them are started by you, and some of them are started by other users on the same system, and some of them are started by the operating system itself. For example, during the boot process. And a single process can also spawn child processes. So a process can be a parent process, and within this process, or within this computer program, it can start other computer programs or spawn other processes, and those processes can also spawn other processes. So if you sort of think about it, the number of processes that can run on a single system can be quite large, and it can be it can require some management very quickly, because just because of the variety and the possibilities that 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 all those different kind of commands or programs that can run on the Linux operating system. So sometimes we need to sort of look into those process management, and try to sort of use the command line to help us to manage all those different processes. One command that allows us to list all the processes that's running on our system is the ps. So by default, the ps is going to list the processes that's run by the user, and at this moment the user is a Pochen. So it's going to list the processes run by this particular user, and it's so if you look at the different columns, you have a PID. It's called a processor ID. So every processor is automatically assigned a unique ID at the time that process starts. So for now, I have two processes, and then TTY means terminal. So at this moment, I have these two processes are all started by this particular terminal, PTS/13. It's an ID for a terminal. And then time, that's the amount of time. It has been running. And then the command for launching that particular process. And you have a bash, that's my shell, and then ps, that's the command that I just executed. So this is actually the default behavior of ps. It's going to list the processes that's started by you and started within this particular terminal. So if you would like to look at the processes that's for example running in the background, and if you would like to look at the processes that's started by other terminal, because on a Linux operating system you can have many terminals also. It doesn't have to be just one terminal. You can have like 10 terminals, and each terminal can launch. You can execute different commands in every terminal. So if you want to look at the jobs issued still by you, but in different all the different terminals, you can use the ps with an option X. The ps command is slightly different from other commands that we have talked about so far. The options or the parameters does not come with a dash sign. It's just a letter. You don't have to type the dash. So you can just the option X allows you to list the processes that started by not just in this particular terminal, but also in every other terminal. So some of the processes are actually so now TTY, you can sort of, if you look into the TTY, you have question marks. That's not exactly issued in a console like a terminal like this kind of thing, but you can sort of see other terminal IDs here. PTS13, PTS1, 9, 13, and some of the process might be sort of started when I logged into the system. For example, this is a process run by my Dropbox daemon, I think, and then that's PSX. If you want to look at the processes that's not just started by this terminal, but also including other terminals and during the startup process, during your logging process, that kind of thing. And that's PSX. And if you would also like to look at the process run by other users, not just yourself, but also the processes started by other users on the same system, including the operating system itself, then there's an option that's called A. And you can combine it with X, so it's gonna list the processes for all users launched in all terminals. And then the list is gonna be slightly long, quite long. Let me pipe it through a more command so I can page it. So you're gonna see a lot more processes, and because this time it's not just my own process, but also all the system's process. The printout of the default PS command is sort of limited to several columns. For example, you have a process ID, PID, then TTY, the terminal, and then the state of the process, the time it has been running, and the command. If you would also like to look at the user ID who launched this process and some other information, for example, the memory usage, the CPU usage, that kind of information, there's an option that's called U. So PS, then followed by the option AUX, and this time it's gonna give you some more columns. For example, you have a user column. It's actually indicating to you the user who actually launched this process. You can sort of see lots of processes that were launched by the root. These are system processes. It was launched by the system itself, the operating system itself, to maintain certain capabilities. And then processor ID, that's the column that we have been looking at. And then the percentage of CPU that you have been using, percentage of the memory that you have been using. These two columns are in percentage. And then VSZ means the virtual memory size. So the Linux operating system has two types of memory. One is called virtual memory. The other one is called the physical memory. And this is the virtual memory could be some hard disk space, that kind of thing. But the physical memory is actually the memory that's installed on your motherboard. And this particular column is actually telling you the physical memory size that this process is actually using. And then TTY, the terminal, the state. We're going to look at the state of the process later on. Start, when the process was started. The total amount of CPU time. This is not sort of the war time, how long it's actually the total amount of CPU time it has occupied. So CPU time is like can be sort of a lot less than a war time, a lot. And then the command that was used to initiate the process. So if you want to sort of page through, you can just use space to page through. What I was telling you is that the one process can spawn other process, can spawn child process. So if you want to look at the relation among different processes, there's another option that's called F. So PSFAUX allows you to look at the relation among different processes to discover what's actually the parent process and the child process. So it's actually using some kind of a ASCII art to indicate the kind of a relationship among different processes. So, for example, this particular process is spawning this process is spawning this process, and then this one is spawning this one, then this one, multiple ones, and then this process is actually spawning these child processes. So it's actually telling you the relation among different processes using some kind of ASCII art, using text strings. I mean, using text to indicate, to draw pictures. That's some kind of ASCII art. So you can use PS to look at the relations among different processes as well. And you can also reverse. Suppose I want to find the processes that's not run by myself. if you want to look at the process run by all users, you have this A option. And suppose you want to look at the process run by not yourself but by other users, you can use the -n. It's sort of the opposite of the A option. This time it's -n, it's not n. This time it's gonna list all the processes run not by yourself. My username on this machine is Pochen, but if you page through all the processes, you don't see any username. That's Pochen. That's because it has filtered out all those processes run by myself. So this -n option is like the opposite of the A option. Let me still go back to A. And sometimes you would like to sort. You would like to sort the processes, for example, according to for example, CPU usage, the percentage of CPU, for example. And then this -- sort option equals 2, and then followed by the column that you would like PS to sort. So this time it's gonna sort according to CPU usage. So it's gonna start from smaller ones and then end with bigger ones, processes that's consuming more CPU. So Firefox is actually consuming like 3.8% of CPU time. And you can reverse the order of the sort by putting a minus sign in front of the percentage of CPU. This time it's gonna put the processes that's using more CPU at the beginning of the list. So now the Firefox is actually using 3.8% of CPU, and it's listed at the top of the list. So you can sort based on the CPU usage. Of course, you can also sort based on memory usage, MEM, for example. Then it's gonna sort everything according to memory. For example, this MATLAB that I'm running is using 3.7% of my total memory, and and then Firefox is using like 2.5% or something. So PS allows you to not just list the processes running on your system, but also to sort them. If you would like to have a better understanding about the status column of the PS output, you can look into the manual page of PS. For example, if I look into process status, well, it's not found. Process state, maybe. No. Okay. So now it's actually sort of listing all the different all the different letters and their meanings. So if you have a big D, it means uninterruptible sleep, usually I/O. Big R means it's running or runnable. Big S, capital S, interruptible sleep. Capital T, stopped. And then W, X, Z. And then it can also have some other keywords, state keyword, some additional character that may be displayed. For example, small s, it's a session leader. This smaller than sign is high priority, not nice to other users. Nice, we're going to talk about a nice command in a little bit later. And then capital M means low priority, nice to other users, and that kind of thing. So now if you go back to the output from the PS, you're going to have a better understanding about what the status symbol actually means. So big S means the interruptible sleep. Small L means what? Small L means what? Is multi-threaded. So using clone threaded like AMPTL pthreads do. This is little L is multi-threaded, that kind of thing. It can have multiple letters, right? It can have multiple letters. Some of them have just a single letter, but some of them can have like 3 letters to indicate the status of or the state of the process. The PS command basically gives you a snapshot of the status of the system and those processes that's running on the system at at the moment that you type the ps command, you execute the ps command. If you would like to keep monitoring the status of the system and the process is running on it continuously, you can use the top command. So the top command by itself is gonna list those running processes on your system, and also keeps updating the status of those processes all the time, as long as you are sort of running the top command. So at the beginning of the printout screen printout of the top command is a set of rows that list the overall information about the system. For example, how much physical memory you are having, how much is used, how much is free, that kind of thing, and what's actually the load average, that kind of thing. And then you have a bunch of columns that looks quite similar to the PS printout. So you have a processor ID, a user, a column for the user, and then a column for PR. PR means priority. And then you have a column called NI. NI means niceness. So niceness is a value that determines how much time the CPU allocates to it compared to everything else on the system. And 19 is sort of the lowest niceness, and minus 19 is sort of the highest niceness. And we're going to talk about the niceness a little bit more later. And then you have the virtual memory, the physical memory, the resident memory, and you also have a column that's called SHR. That's sort of the shared memory size in kilobytes. And then you have a column that's the status, and then a column for CPU, the percentage, CPU's percentage, and then a memory percentage, and then the total amount of CPU time it has used, and then the command, the process, the name of the process that's actually running on it. And the top command actually has some nice features. So suppose you would like to sort of kill a certain process. So inside of the terminal window, inside of the top command, you can type the key K. As soon as you type the K, it's gonna ask you the processor ID to signal kill. So suppose I have a bunch of processes that's running on my desktop right now. So if I want to, for example, I want to kill the Firefox process. It's been running for it has been using like 281 CPU hours of CPU time, or that kind of thing. And then it's kind of sleeping now. I don't want to sort of keep it running to occupy my memory and resources. I can just give it I can just kill it. And the thing that I want to enter is the process ID, PID. That's 9175. So as you can see, as soon as you type the key on the keyboard, the updating actually stopped. So it will allow you to actually to find the process ID better. So if it keeps updating, it's kind of hard to keep track of to find what's actually the process ID for a particular process. So now I want 9175. I'm gonna kill the Firefox process, and then just type enter. After you have typed in the process ID, just type enter, and then it's asking you what kind of signal you want to send it to that particular process. At this moment, you have two choices. One is 15, called SIG term. That's sort of the default behavior. So if you type enter now, then it's just going to send a message to that process, to Firefox process. That message is called a SIG term message. So it's going to ask the process to terminate nicely. So it's going to ask the process to finish up, and then stop running and finish up. And there's also another signal that you can send. That's number 9, and number 9 is it's called a SIG kill. The meaning is that so the process has to terminate whether the process itself likes it or not. So it's just some kind of forceful kill of of a certain process. So here I'm just gonna use the 15. That's the default. I'm gonna just type enter. And then after a while, you can sort of see my Firefox actually has disappeared because it has been killed. That's one of the utility. So you have to type the K key on your keyboard in order to actually kill a certain process. You can sort of see there's a number of columns here. In fact, the information that this top command can display uh, is not limited to those columns, and you can actually select the fields that you want to display by using the F key. So if you type F, then it's going to switch to this particular window, and it's actually telling you how to use this particular screen to select the fields that you would like to display. Suppose I would like to display parent process ID, for example. I can just use my arrow key to navigate to this particular field, and then use the space key. Use the space key to select it or deselect it. Use the space key, and if I want to sort of for example, display don't display shared memory, I can just use my arrow key, navigate to there, and then use my space key to disable it. Just type the empty space key, and then you have a sort. You have a set sort. For the default behavior is that it's gonna sort according to the CPU percentage, and it's actually telling you the current sort field is CPU percentage. So suppose you would like to sort according to the memory percentage, then you can use your arrow key, navigate to %mem, and then type the letter S. So here it's telling you S set sort. If you type S, then now the sort field now has become %mem, and it's actually telling you that. And use quit to end this. And now if you go back, I have typed the Q key. If you go back to the listing, then it's gonna rank or sort all the different processes based on their memory percentage use. Now MATLAB has jumped to the first because it's using 3.8% of the memory. And CARSARM, that's actually the computer program I'm using for making the screencast. It has 44.1% of CPU usage, but now it's ranked number 3 because its memory use is like 1% of the memory. So if you want to go back to the default behavior, you can still type F, go back to the field selection, and then use your arrow key to navigate to %CPU, and then use S key to change the sorting to the %CPU, and then use Q key to escape. So you can the F key has some utilities. If you pay attention to the printout on the screen, you'll find that some of the numbers are in bold. So by default, it's gonna bold some of the fields. You can turn that on and off by using the capital B letter. So you have to hold down the Shift key and then type the letter B, and then it's gonna turn off the bold in the header fields. If you want to turn it back on, turn the boldness back on, use the capital B letter again. Then it's gonna turn on the boldness for the header fields. And then there's a key called X. The X key, if you type the X key, then it's gonna bold the column that's used for sorting. So if you want to turn it off, just type the X key again. For now, the percentage CPU is used for sorting, so if you use the X key, it's gonna bold the percentage CPU column. If you want to turn it off, just use the X key again. And then there's another key, Y. Y key is for making the for making a process for making the running process bold. So if you look at the status column, many of them are actually in sleep. So many of the processes are actually in sleep. If you want to make the running process, for example, the R process, the process with status of R running process bold, you can use the Y key to turn it on and off. So that's boldness, and the three key that's controlling it is the capital B, X, and Y. Um, the last command that's kind of useful is the R command. R command is a tool that allows you to reset the niceness of a certain process. It's the R key. So again, it's gonna ask you to enter a processor ID, and the screen has stopped updating. So it's gonna so suppose I want to sort of change the niceness to this particular top command that I'm using. Or for example, the Skype command that I'm using. For example, I can give it 21685. So I want to make it a nicer. I want to make it nicer. So what I'm gonna do? I'm gonna increase the niceness number from 0 to like a 5 or something. So now you can sort of see the Skype actually has a niceness that's being changed to 5 now. So niceness is can be reset using the R key. If you would like to quit the top command inside of this kind of updating window, you can just type the Q key, and then it's going to quit the top command. If you would like to select the processes that's launched by a particular user, you can use the U key. So if you type the U key on the keyboard, then it's going to bring out this dialog, which user, blank for all. So at this moment, if you type enter, then it's going to select all users. But if you type the username, for example, I want to just look at the processes launched by PoChan, this particular user ID, I can just type the user ID here, and then return. Then it's going to filter out the processes launched by all the other users except for the PoChan. And if you want to bring back the processes run by all the other users, you can just type the U key again. And then this time you just type enter without specifying a particular user ID. Then it's going to display the processes running by all the other users now. That's the U. U allows you to select users you want to display. The Linux shell has the concept of foreground jobs and background jobs. So foreground jobs are those processes with control of the terminal, and the background jobs are processes without the control of the terminal. Sometimes some of the commands or some computer programs can take a very long time to run. So if you type the command and press return, and then you have to sort of wait for it to finish. So in this kind of case, it might be better to put this job or put this process into the background so that your terminal or shell is freed up for you to type other commands. Let's try to do a command that's gonna take a very long time to run. Let's do a find command. I'm gonna find in my current directory dot, and then I'm looking for ordinary files. So it's a type F, and then I'm gonna use an option that's called a printf. So printf is an option that allows you to print out the information of the files that you have found in a nice way, in a formatted way. So %s actually means that I want the size. I want to print out the size of the file. And then I'm going to use a \t, which means I have a tab key. I put a tab between two fields. And then I'm going to use a %p. %p actually means the file name actually. It's just the file name, and then I'm gonna use \n. \n is an escape, is a representation of a new line. So each file is gonna be printed on a new line. So if we talked about the dash type option, but we didn't talk about the dash printf option. If you are not familiar with the dash printf option, you can look into the main page of find, and then just search for dash printf. Now it's telling you how to use the dash printf now, and some of the so \n represents a new line, \t horizontal tab. The percentage signs have different meanings actually. The percentage sign is a placeholder for you to put different fields into it. So we used the %s and %p, I think. So %p actually means file's name, and then %s means file's size in bytes. So that's my find command, and I'm gonna pipe through. I'm gonna put the output of the find through a sort command, a numerical sort. I'm gonna sort the output of the find numerically according to the byte size of the files. So this is the vertical bar means a pipe. It's a way for connecting two commands together, and we'll talk about the pipe and redirections, that kind of thing, how to combine commands in a later video. So this particular command is going to take a long time to run, and if that's the case, the terminal is sort of tied up, and I cannot really enter any new commands and do anything else. So if that's not what you wanted, you can use the Control-Z key. Hold down the Control key, CTRL key, and then press Z on your keyboard. And then it's not going to tell you that this process has been stopped. It has been suspended actually. At this point, you can type the letter BG. BG means background, which means that you are actually putting this process into the background. And it's actually echoing back this particular command for you. So this command is exactly what you actually have typed, with one exception. The exception is that it puts an ampersand, this particular symbol, at the end of the command. Okay, so the command has finished. And it's printing out all the stuff on my home directory. And then maybe you can bring it to the foreground. FG means foreground. So FG means foreground. So you're bringing back the execution of the command to the foreground now. And at this moment, if you want to stop the execution of this command, you can use Control-C. Just hold down the Control key and then press C on your keyboard. Then it's gonna stop the execution of the command. So if you want to issue a command or launch a command in the background, what you can do is to first you issue the command itself, and then use Control-Z, and then put it into the background. That's one way of doing that. And this particular way of doing that is actually equivalent to typing this particular command with the ampersand following the command itself. If you want to bring a command into the foreground, just type the FG key. And then you can stop it by using Control-C. Another way of launching a program in the background is to use ampersand. So in this command, I'm actually trying to find all the files in my root under the root directory, and then print them out, print out the size and also the file name, and then sort the files according to the size. So here I have ended the command with the ampersand because I'm gonna search on the root, so I'm gonna need the administrator privilege. So I'm gonna do a sudo, and as soon as I type this command and press return, it's gonna go back to the terminal prompt and asking me to do to type other commands. So it's not gonna tie up the terminal. So I can still enter other commands for the system to execute. And it's returning me two things. One is the number that's in the square bracket. That's the job ID. So it has a job ID of 1. So it's the first job running in the background, and then that's the PID. So because the terminal is not tied up here, I can type PS and list all the commands that I'm doing, that I'm looking at. So 18842 is a processor ID for the sort. 18842, that's processor ID for sort actually. So another command that I can use to check on the process of the background jobs is to use the jobs command, and then it's going to display the job ID, the status of the job, and then the command used for launching the job. And in this particular case, it's giving you a job ID of 1. Now, suppose I do another command, for example. So basically, I'll just type this same command again. Let's just neglect about this particular printout for now. So now it's giving me a different job ID. It's giving me a job ID of 2, and then another process ID. So if I do a PS now, I have 2 sorts. One is 18842, the other one is 18847. And then I have, if I do jobs again, now I have 2 running background jobs. So if I want to sort of bring one of the background jobs into the foreground, I can use the FG command. Suppose I want to bring the first job to the foreground, FG followed by 1, and then it's gonna bring the processor to the foreground. If I want to interrupt the execution of it, type Control C, then it's gonna stop the execution. So if I do jobs now, I have just the second processor that's running. If I want to bring it to the foreground, I type FG2, and then it's gonna bring the second command to the foreground. If I want to stop its execution, just type Control C, and then if you do jobs again, there's no more background jobs running. So the tools that we have looked at so far, the ampersand allows you to put a job into the background, and then FG allows you to bring a job to the foreground. BG allows you to put a foreground job into the background. And then the jobs command allows you to list the status of the background jobs. You can kill a job by using Control C. A word of caution is that if you actually put some processes in the background, and if you close the terminal by pressing this key, you close this terminal, and then all those background processes launched inside of this terminal is going to be killed. So suppose I want to do suppose I'm going to repeat this particular command. I'm going to do a sudo find this kind of thing, and I'm going to, so I'm going to put it into the background, Control Z, BG. So this process now runs in the background and then now if I close my terminal, I type exit. For now, it's sort of not really exiting because the terminal itself knows that there's a background job running in the background. But if I close this terminal by pressing the close button, and then if I reopen the terminal, and then if I do a PS or jobs, there's no background jobs running. Even FG is not going to bring the background job to the foreground anymore because that background job has been killed. So what might be the proper way for you to keep a job in the background running for a very long time and then close the terminal without killing that background job? You have to use the screen command. So you type screen, and then it's gonna give you some information about this particular screen program. Press space or return to end, and now it's giving you a new prompt. Now let's still do sudo. This command. It's asking me password, and then let's put it into the background. Control Z, and then BG. Now, if I do jobs, you have a process running in the background. So this is the inside of the screen program. If I want to go back to my original terminal, I hold down the control key. Hold down the control key without releasing, and then type the key A and D inside of the background on the keyboard. Then it's gonna bring you back to the original terminal you were in, and it's actually echoing back detached from this particular terminal to this particular screen. At this point, you can just close this terminal. Now, if you actually reopen a new terminal, you can reattach to the original screen by using the command screen-x. And then now you're back to the original screen where you actually issued this particular find command. And it's actually printing out the stuff that's the result of the search. And you can just use Control-C to stop it. And if you want to end a screen, if you want to terminate a screen, you have to type the exit key. Exit. You have to type exit in the prompt. And now it's telling you the screen is terminating. It's not the terminal is terminating. The screen is terminating. The previous screen has been killed. If you want to reattach to the original screen using -x, it's going to tell you there's no screen to be attached. And you can also issue multiple screens. So if I do a screen, I can do some commands, do some stuff, and then detach it by Control A and D, and then I'm detached from this screen. I'm going back to my original terminal. I can open multiple screens. I can type screen again. It's gonna give me a new screen. If I do another command, for example, do a find dot type name temp, type D name temp, and then detach it again. So now I have two screens. I have two screens running in this terminal. So if I do a screen -x, try to reattach, it's going to tell me I have two screens detached. So I have to follow the screen -x with a screen ID. If I want to go to one of the screens, for example, 20138, I can do screen -x 20138, and then it's going to get me back to the first screen that I opened. And if there's any program that's running in here, I can kill it or do what I want with that process, or bring it to the foreground, that kind of thing. If I want to terminate this screen, I type exit. It's telling me screen is exiting. If I do screen X again, it's gonna be automatically attached to the second screen that I opened. Because for now there's only one screen that's left. So if I do exit again, there's no screen to be attached anymore. So you can, so if you wanna leave a background process running and then close the terminal without killing that background process, the screen is the right command to use.